Hi everyone, welcome back to Engineering Statistics. Sorry that we have to lecture in a blended learning form this week. So last 2 weeks we have learned about CRV and we have learned about DRV, but actually most of these are just one variable. There are so many conditions that we deal with more than one variable. So therefore, we are going to learn about bivariate probability distribution, which means that you have more than one variable in the same condition. So for example, in your gas efficiency of a car, your efficiency of a car is not only depends on the weight of the car, it depends on the aerodynamic of your car and so on. And for example, success in college based on high school performance. Before you come to your degree, they evaluate your CGPA, they evaluate your curriculum, right? So there are so many variables, factors that affect your outcome. And therefore, we are here. So even though you have two variables, you are still stick with the two basic probability function rules. The first one is the probability function should be between 0 to 1. The total should be not more than 1, is always equals to 1, right? And when we have two variables, sometimes I just want to know what is the variables of probability function of one variable. For example, for DRV, discrete random variable, so I would like to know that's called marginal probability. I would like to know the marginal probability of X. So then I have to find the total of Px equals to 1, Px equals to 2, Px is equals to 3. Whereas for the marginal probability 1, Y, so I have to find them one by one. What that means is, I give you an example. So this is the example, for example. So I would like to find the marginal probability of y equals to 1. What is that means is my y is fixed, okay? My y here is fixed. But my x is keep on changing, 1, 2, and 3. So therefore, the total marginal probability y equals to 1 is the summation of the whole thing is 0.6. So the marginal x equals to 1, at this part, my y is keep on changing. So my total is 0.3. Do you get it? Okay. So the probability of x equals to 1, y equals to 1, that's super simple. X equals to 1, y equals to 2 is x equals to 1, y equals to 2 is 0.1. That's so simple. Okay, now you understand what is the difference between the how to find the marginal for the DRV. It's quite simple. So let's say I have my x has a lot, and then my y is y have different as well. So the simple one is you add another column for each of them, and then you show them just like this one. So you don't need to show the you don't need to show the pink box, but you just need to show this is the marginal of py equals to 1. The x is keep on changing, right? So you add them all, you can get it. Does that make sense? Okay. Whereas for the marginal x equals to 0, that is 0.3. Okay. So besides that, we also need to know about the conditional probability distribution. What that mean is, so for example, for the first one, P1 x stroke y. So in this case, it's actually y happened first. Given that y happened first, then x. So because the whole thing is controlled with the y condition, and therefore the bottom of this is y. Okay? In the upper part is Bayes theorem. So probability A stroke B is actually equals to probability A and B over probability B. Same case here. So in this case, it's probability X and Y over P Y. So for the P Y stroke S, in this case is X first. So therefore the bottom one is PX, right? So you can try this example and see whether you can find the same value. So I think something that we can discuss here is the C part. Okay, find the conditional probability distribution P probability X equals to 0 Y. So in this case, the Y is keep on changing, right? So therefore you have to find because Y only have 0, 1, 2. So you can find X equals to 0, stroke Y equals to 0, find the value. X equals to 0, Y equals to 1, find the value, and so on. That's the difference, okay? Yeah, so we also can try to look at this part, okay? What is the probability that tire expert X will assign grade 2, given that the tire expert Y assign a grade of 1? So everything that given that means Y happened first. So therefore, Y happened first is 1. So Y equals to 1. Given that there's a stroke, X equals to 2. So Y first, given that means given that the condition Y happened first. So PX equals to 2 and Y equals to 1 over the PY equals to 1. So X2Y1. X2Y1 is 0.1. Summation of PY is 0.23. Okay? Okay, done. So what about CRV? So for the CRV, the same thing also. The total of the distribution is always equals to 1. Whereas for the and the formula, it should be the integration of dx first. If you look at this, then only dy. If you want to have your probability density function set very simple, do the differential equation, then you can get your probability density function. Okay, for example, this one. Consider joint probability function of CRV below. So what you need to do is actually first, okay, 1 to 0, because it's given X is 2 to 0. So X 1 plus 3Y over 4 dx dy. Okay, so if you look at this, right, we do the integration of this one first. Therefore, X over 2, and this whole thing we can assume is constant. Okay, 1 over power 1 plus 3y power of 2 over 4 times 2. Okay, and then 2 0 dy 1 0. Okay, so now assume you have to remember this is constant, yeah. So 2, then first you put in the value. So 2 to 4 over 8, 1 plus 3y power of 2 dy 1 0. And I can simplify this as 1 over 2, right? And then after that, you can move 1 over 2 out. Okay, 1 plus 3y over 2 dy. Okay. So what you can do now is do the integration. So when you do the integration, okay, add y plus 3y over 3 over 3. Okay. 1, 0. Therefore, 1 over 2. Y is 1 plus 1. Is it? Because 1 plus 1 is 2, so therefore your answer is 1. And you can get the answer, same answer as this. Is that okay? It's just about integration or differentiate. If you're not familiar, go back and practice again. Okay? So same thing with this. Determine the value of C constant. So we know that the total cumulative probability function is equals to 1. So you can use this equals to 1, and then you do the integration step by step, and you should able to find your C equals to 2. Try it first. If you have problem, just come back to me. Okay, what about the marginal probability density function of CRV? So same thing, but it's a bit different because this is CRV. So if you're looking for marginal fx, remember just now, when we go for the marginal x equals to 1, what is changing? The changing is y dy, same as this one. So because you're looking for the marginal x, the changing one is dy. Therefore, you integration with dy. When you look for the marginal y, the changing one is x. Therefore, you doing the integration with dy. Does that make sense? For the condition, just like the DRV, so who first, then it will be at the bottom. Okay? Who first, that will at the bottom, that's the marginal probability of the y. And don't forget, this one is, you can have to use the marginal probability. So the marginal is when it's x, the changing is dy. And therefore, when you are looking for y, then you have to use dx. Okay? So we learn about marginal, we learn about the condition. In the DRV and CRV, we learn about expected value as well, right? So do you remember this? So yeah, we need to find the expected value. So for the expected value, we are using, if you are using the DRV, looking for the mean, so what you need to do is you just add the xy here. Okay, you just need to add the xy in front of your bivariate function. Well, for the CRV, same thing, you need to add the xy in front with your bivariate function formula. So let's have a look on the example. So if I would like to find the mean of this process, this condition, then I have to find the total of x, y. So x and y, okay, x is 2, y is 0, times the probability. And I have to do all the summation. And then you can get your mean. Whereas for the CRV, like I mentioned to you, you need to add the xy in front. So once you have x, the xy, the whole things is just the same, like the integration that we have done just now. Okay, like the joint probability function. So again, dx first, then after dx, then you do the integration of dy. And remember the condition. For example, this equation is 2x. Okay, right? Can you see the dx? Fxy is 2x. So for this one, so I have to put, sorry, if you're looking for the mean for the x, if you're looking for the mean for the x, then you are adding the x, adding the x. If you're looking for the mean for the y only, you add the y times the y. If you're looking for the EXY, then you have to times the XY, okay? Let's say I would like to find the EX, the mean for the X. So I just times the X in front here. So do the integration as usual, and you can get your mean. If I would like to find the the mean for XY, okay, the joint density function, so I have to time the XY in front with the